Welcome back to Aurora Tech Channel. Today, I will review the Creality Sermoon D3. Creality has always dominated the hobbyist 3D printer market in terms of market shares. They recently launched the Sermoon D3 and want to use it to enter the professional and high-end personal market, which is currently dominated by Ultimaker. So, in this video, I will do more than just test the Sermoon D3. I will also do a head-to-head comparison between it and one of my favorite printers, the Ultimaker S3, and see if it can become a challenger for Ultimaker in the business 3D printing market. Let's take a look at the hardware and features of the Sermoon D3. It's a fully enclosed printer with an injection molding enclosure and acrylic side panels, a top cover, and a door with a sensor that can be made to pause the print when the door is opened. The frame is constructed by aerospace aluminum profiles. The X and Y gantry on top is CNC machined 8mm thick aluminum. The bed is 12mm thick aluminum, and the base is made of steel, making the total weight of the printer around 100 pounds. The printer uses high torque stepper motors and has higher quality timing belts and wheels. The extruder is a redesigned Sprite extruder with a different heatsink, and it can still reach up to 300 degrees Celsius for high temperature filament. It uses two 50-15 blowers, one for hot end cooling and one for part cooling. For bed leveling, it uses a CR Touch and has added a sensor to set the Z offset automatically without having to do the paper test to set the nozzle height. It also added a silicone wiper for nozzle cleaning. The build volume is 300 by 250 by 300. For the printing speed, it claims to print PLA 2 times faster and print ABS up to 5 times faster than regular printers. The enclosure also comes with exhaust fans and 2 HEPA filters. As for the print surface, it comes with a PEI and a PC flexible build plate. This printer supports Creality cloud printing, but you can also send print jobs over your Wi-Fi network without using their cloud, or use a USB drive to print offline. As for the other features, there is a 32-bit board with silent stepper drivers, an HD camera, a 500-watt power supply, a 4.3-inch touchscreen with a new UI, and an extra hardened steel nozzle and hot end kit. The hardware specs of this printer are quite different from other Creality printers, and so I'm really excited to test it out. I would like to thank Creality for sending me this machine to review, and with that, let's get started. The machine comes in one piece. No assembly is required, and all you have to do is remove the protective foam and film on the acrylic. Okay, we can now turn on the machine. Select Language and select Confirm to move the print bed up in order to remove the remaining foam underneath the bed. Select Confirm again after that, and the print bed will lower itself, so we can put one of the build plates on the bed. Then it will start leveling. The CR Touch will probe 3 points on the bed and conveniently tells you how many degrees you need to turn the knob. After that, it will heat up the nozzle and do some cleaning by wiping the nozzle on a silicone wiper at the back of the print bed. Next, it will automatically set the Z offset using the sensor next to the silicone wiper, followed by a 25-point auto bed leveling. Okay, it's done, and we finally don't have to use a piece of paper or a leveling card to do bed leveling. The printer shows that we can now insert some filament. I will use the roll of filament that came with the printer, which is a new roll of HP Ultra PLA. This printer has 2 places to mount your filament. One of them is on top and one is inside the machine. I will try to mount it inside. The side panel is actually a door, and it provides easier access for loading and unloading filament. Insert the filament, run it through the filament sensor and the reverse Bowden tube, which works as a guide to the extruder. Press Confirm again, and it will extrude some filament. Once the filament is coming out, you can press Confirm again. Now, the screen tells you to insert the USB drive, and we're ready for the test prints. There are 2 sample files, but neither show the estimated printing time. So I'll try the vase as a model using vase mode to just print the bottom and wall, as this will normally make it print faster. this model took 50 minutes to finish. The surface looks pretty nice, the bottom sticks perfectly, and it seems the Auto Z offset sensor is doing a pretty good job too. Okay, I will now do some more test prints in order to compare this printer to my Ultimaker. I will start with a 3D Benchy, and I will print it with the same Creality HP Ultra PLA. For the Ultimaker S3, I will use the Ultimaker Green PLA, which costs $50 for 750 grams. Both benches look really good, though there are some very minor issues on the Ultimaker one, that being the salmon skin at the bottom, as the noise of the Ultimaker is a bit loud, and the chimney also shrinks a bit too much. The Sermoon D3's benchy is pretty much perfect, and the white color HP Ultra PLA also hides the layer lines pretty well, making the layer lines especially hard to see on camera. I also printed a calibration cube with both printers. The cube printed by the Sermoon D3 with HP Ultra filament still looks great, but the Ultimaker one seems to be having some cooling issues. To make sure this huge quality difference was not caused by the different filament, I decided it would be better to use the same brand, same type, and even same color filament, except with different diameters, as the Ultimaker uses 2.85mm filament. So I contacted Polymaker, and they sent me 8 different types of filament in 2 different diameters, including PLA, PETG, ABS, ASA, TPU, polycarbonate, nylon carbon fiber, and nylon glass fiber. Let's reprint the benchy with the same Polymaker PLA filament on both printers. It seems the quality of the Sermoon D3 really is better, and it's not because of the filament. If there was no comparison, both of them would be just pretty decent benchies, but when comparing the two, we can obviously see the one printed by the Sermoon D3 is better in all of these areas, and the overall surface is also cleaner due to less ringing. When you take a look from the front, the ringing and cooling of the Sermoon D3 are still better. Let's print the calibration cube again. As you can see, the result is fairly similar to the benchy. The layers are cleaner on the Sermoon D3, and the cooling of the Ultimaker S3 also is not as good as the Sermoon D3, especially on the X surface. For the Y and Z surfaces, the results are similar, but the layer lines of the Sermoon D3 are still better thanks to the super sturdy frame. Let's take a look at the print head cooling fan of both machines. The Sermoon D3 is using a 50mm 50-15 blower and a fan duct that will redirect the air to blow from both sides. The Ultimaker S3 uses 2 smaller 30mm fans, but their angle is pretty much straight down and slightly inward, which is not an optimal cooling angle. This is why you can see some Ultimaker users modding their part cooling fan to get an optimal angle, but I'm not sure if I want to do this DIY mod on a machine that costs close to $5,000. Next, we will try one more PLA print, and let's do a tough model, the Eiffel Tower. For a model like this with tiny details, the larger you make it, the better result you get. But as I'm limited to the print volume of the Ultimaker S3, I will print a 195mm tall tower on both printers. As we scaled down the model to this size, neither printer printed very well. Let's take a closer look at the lower part of the tower. The Sermoon D3 has some stringing, but the structure of the tower is still alright. For the Ultimaker S3, the Bowden setup shortcomings are clear on this model as it requires an excessive amount of retraction, so it looks even worse. For the upper part of the tower, many structures are missing from both prints. When you take a look at the tip of the tower, you can see the Creality print slicer actually cancels out some details, but overall, the Creality Sprite direct drive extruder still did a better job than the Bowden setup Ultimaker. After that, I will print an adjustable phone stand with PETG. The one printed by the Sermoon D3 is actually a different color of PETG, while the one printed by the Ultimaker S3 is a more regular and shiny black. Both of them were printed successfully, and the surfaces of both look alright. The layers of the Sermoon D3 are slightly smoother, but overall, the difference is not that big. They are both functional, and the angle of the stand can be adjusted easily by turning the knob. Then, I will print my own design of a simple filament mount with ABS. I tried to change the print surface of the Sermoon D3 to a flat surface and apply some glue. I fully enclosed the printer as my garage temperature at night is just around 15 to 16 degrees Celsius. After the print is fully enclosed, the temperature inside can reach around 45 degrees Celsius. For the Ultimaker S3, as it doesn't have a top cover, I actually moved it to the living room where the indoor temperature is around 70 degrees Fahrenheit or 21 degrees Celsius, as it may not be ideal to print in my cold garage. Both prints turned out very nice, with no warping or layer separation. The Ultimaker S3 printed fairly well, but when we zoom in really close, the layers of the Sermoon D3 are still slightly better, and the details at the corners are slightly cleaner. The bottom corner of the Ultimaker's print actually lifted a bit, but this won't keep the model from functioning. Up next, I will print with some ASA. The parameters are actually pretty close to ABS, except that the printing temperature is slightly higher at 260 degrees Celsius. I forgot to remove the brim from the ASA profile of the Ultimaker, but with my favorite Elmer's Craft Bond Extra Strength glue stick, I believe that with or without the brim, it won't warp at all. Both prints were successful with no warping at all. When we zoom in closer, the layers do look better on the Sermoon D3 as it's fully enclosed. The overhanging part and the surface also look a little better on the Sermoon D3. Then, I will try printing some TPU. Polymaker TPU is actually 90A, which is a little softer and more flexible than regular 95A TPU. This may be a little challenging for the Ultimaker's Bowden setup, but let's see how it does. As the top part of the model is overhanging, without support, neither print was finished well. I will just trim off the detached filament and take another look. The Sermoon D3 is still a bit cleaner, while the Ultimaker S3 has a little under extrusion, as the 90A TPU may be a bit too soft. The bottom of the print looks good, the glass bed of the Ultimaker provides a mirror finish, and the PEI sheet of the Sermoon provides a textured finish. However, the overhanging at the cutouts printed by the Sermoon D3 look better. The side buttons of the Sermoon D3 also look much cleaner, which is mainly because of the direct drive extruder, which handles retraction better, especially with this softer TPU. Next, I will try some polycarbonate. This requires a 285 degrees Celsius nozzle, so I have to switch to the high temperature print head on the Ultimaker S3. The prints turned out great on both printers, and the threads are both clear. But when I tried to turn the knob, the one printed by the Sermoon D3 is much smoother. The Ultimaker S3 is also functional, and without comparing, it's still a pretty decent print. But when comparing, the Sermoon D3 still prints a bit better in terms of accuracy. I will now print another cable roller with the same polycarbonate filament. This model is divided into two parts, and it's also a good model to use to test accuracy. Both prints can fit together without issues, but the layers on the Sermoon D3 are still cleaner. And personally, I prefer the textured bottom from the Sermoon D3. Now for the accuracy test. The roller printed by the Sermoon D3 turns smoothly. The one printed by the Ultimaker can be turned, but some force is required. Then, I will try printing with nylon glass fiber. This is one of the toughest materials to print nicely with, but it seems both printers can print nicely with this material. Let's zoom in to take a closer look. The Ultimaker already prints pretty good, and at least does better than most of my printers, but the Sermoon D3 still prints slightly better on this fin, as well as the screw holes at the back. The box actually contains two parts. We printed the lid with nylon glass fiber, but let's print the box body with nylon carbon fiber. Similar to the glass fiber lid, they were both printed quite nicely, but when I zoom in really close, the layers and the details on the Sermoon D3 are once again better. However, they both printed better than average. Without the comparison, I would say the Ultimaker S3 is doing a pretty good job, but with this side-by-side comparison in terms of details, the Sermoon D3 wins. These are all of the prints I've done on both printers. Obviously, the Sermoon D3 prints better in all materials, but before I go through a full comparison of these two machines, I would also like to do a speed test on the Sermoon D3. It claims to print ABS fairly quickly at 250 mm per second. This is not super fast, but I still want to test it out and see how much quality is lost when printing at high speeds. First, I will print an ABS Banshee at a standard 80 mm per second speed as a baseline. As you can see, the actual printing time is 1 hour and 19 minutes, which is not bad compared to a regular speed printer that would require an hour and 50 minutes. Then, I will print one at top speed at 250 mm per second. The print took 37 minutes and 33 seconds. It's not bad, but we can see some ringing and the surface is not very clean. Let's compare it with a standard speed Banshee. It's not a huge difference, but I won't say it can print fast without losing quality. Printing at a standard speed looks better in terms of layers, surface, and ringing. The 37-minute Banshee is not great, but it's also not too bad. Okay, after doing all the test prints on the Sermoon D3 and the Ultimaker S3, I want to do a detailed head-to-head comparison between these two printers. I will compare them in 20 different areas and score each area from 1 to 10. I will compare their hardware, print quality, software, workflow, UI, service, documentation, as well as other factors beyond the printer itself. However, these are all based only on my personal opinions, and different people may weigh things differently. Let's start with the hardware. For the motion system, they both use linear rods. The size of the X linear rods on the Sermoon D3 and the Ultimaker are both 10 mm, but the Y linear rods on the Sermoon D3 are 12 mm and the Ultimaker is 8 mm. For the Z-axis, the rods on the Sermoon D3 are 16 mm and the Ultimaker's rods are 12 mm. I will give 8 points to the Sermoon D3 and 7 points to the Ultimaker S3. As for the rigidness of the frames, the Sermoon is constructed using aerospace aluminum profiles, CNC machined aluminum, and steel. The frame of the Ultimaker is the 6 mm plastic board, but it's still pretty sturdy, so I will give 8 points to the Sermoon D3 and 7 points to the Ultimaker S3. For the print bed and Z-axis frame, the Sermoon D3 uses 12 mm thick aluminum with a one-piece support frame. Although it's only supported on one side, it doesn't move at all, even if I put a whole kilogram of filament on the far side of the bed. The Ultimaker S3's bed is also supported on one side, and though it's still pretty sturdy, it's not as good as the Sermoon D3. I will give 9 points to the Sermoon D3 and 7 points to the Ultimaker S3. For the extruder, the Sermoon D3 is using the newly designed Sprite extruder with the larger heat sink, and the Ultimaker is using a Bowden setup with a pretty strong feeder. The Bowden setup really shows its disadvantages when printing models that require an excessive amount of retraction. I will give 8 points to the Sermoon D3 and 7 points to the Ultimaker S3. The Sermoon D3 also only has one extruder, but the Ultimaker S3 has a dual extruder that can print 2 colors or water-soluble filament for models with complex structures. So I will give another 7 points to the Ultimaker S3 and 0 points to the Sermoon D3. As for the build volume, the Sermoon has a volume of 300 by 250 by 300, and the Ultimaker S3 has a volume of 230 by 190 by 200. So I will give 7 points to the Sermoon D3 and 5 points to the Ultimaker. For the enclosure, the Sermoon D3 is fully enclosed. As my garage's temperature is around 16 degrees Celsius and the humidity is about 40%, after closing the door and the top, the inner temperature of the printer can reach higher than 46 degrees Celsius, which is 30 degrees higher than my room temperature, and the humidity also dropped to 2%. The Ultimaker S3 doesn't come with a top cover, so I will give 8 points to the Sermoon D3 and 6 points to the Ultimaker S3. After comparing all these factors, the hardware score of the Sermoon D3 is 48 and the Ultimaker S3 is 46. Basically, the Sermoon D3 has better hardware than the Ultimaker S3 in almost all areas, but Creality missed an important point, which is the dual extruder. So the final hardware scores for both printers actually come pretty close. Next, let's compare the actual printing of both machines, including the print quality, print speed, and printing noise, starting with the first layer quality. The calibration of the Sermoon D3 is really easy. The sensor will tell you how many degrees you need to turn the knob. After that, it will use the sensor at the back to set the Z offset automatically and do auto bed leveling. I got a perfect first layer on every single print, which is really impressive. For the Ultimaker, it uses the traditional method, which requires a card or paper to set the nozzle height, and it uses the nozzle to probe the bed for auto leveling. This still works, but the first layer is a little bit squeezed, and you need to apply glue for most prints so that they stick well. I will give 9 points to the Sermoon D3 and 7 points to the Ultimaker S3. For print quality, as this part is the most important part of a 3D printer, I will divide it into 3 parts. For regular materials like PLA, PETG, ABS, and ASA, the Sprite Direct Extruder prints much better than the Ultimaker Bowden setup, especially on the Eiffel Tower, which requires an excessive amount of retraction. For other PLA prints that require cooling, the angle of the cooling fans on the Ultimaker S3 is not optimized, so you can see some Ultimaker users modding them to get better cooling. For PETG, ABS, and ASA, the Ultimaker S3 prints pretty well, but the Sermoon D3 still prints slightly better on every single print. So, I will give 8 points to the Sermoon D3 and 6 points to the Ultimaker for regular materials. For flexible filament, the Sermoon D3 Sprite Direct Drive obviously prints better and faster, and it can print at 60 mm per second with good results. For the Ultimaker S3, as it's a Bowden setup, the default print speed for TPU is set to 25 mm per second, which is slow. However, the results still isn't that great. For flexible filament printing, I will give 8 points to the Sermoon D3 and 6 points to the Ultimaker S3. For engineering-grade filament like nylon carbon fiber, nylon glass fiber, and polycarbonate, I knew the Ultimaker already printed them pretty well. Before I tested out this Sermoon D3, I always assumed that when printing nylon carbon fiber or glass fiber, the results may not look as good as PLA, and the Ultimaker S3 probably gives the best results I can get. But let's just have the results speak for themselves. The Sermoon D3 prints nylon carbon fiber and nylon glass fiber perfectly. I've never seen anything like these on any printer, including all 70 printers I've previously tested. For polycarbonate prints like the phone mount and the cable roller, the accuracy of the Ultimaker S3 is alright as it can still fit, but it's not very smooth. So, for engineering grade materials, I will give a perfect score of 10 points to the Sermoon D3 and 7 points to the Ultimaker S3. For print speed, the fast print profile of the Sermoon can print PLA at a 150 mm per second speed with an acceleration between 1000 to 3000 mm per second squared. For the Ultimaker S3, the fast profile is set to a 70 mm per second speed with an acceleration between 1000 to 3500 mm per second squared. So, there is no big difference in the printing speed of PLA. Both printers take a little over an hour to print a 3D Benchy. But for ABS, the Sermoon D3 can print at 250 mm per second in speed, even with the same acceleration, and the fast Benchy that I printed with ABS could be finished in 37 minutes. For the Ultimaker S3, the fast ABS profile is set to 60 mm per second speed with 3500 mm per second squared acceleration, and the Benchy will take around 1 hour and 25 minutes, so the Sermoon D3 can print ABS faster. As both printers don't look super fast to me, I will give 7 points to the Sermoon D3 and 6 points to the Ultimaker S3. For printing noise, the Sermoon D3 is the clear winner. When the door is open without the top cover, the noise is around 55 to 60 decibels, and when it's fully enclosed, the sound level is below 50 decibels most of the time. On the other hand, the Ultimaker S3 printing with the door open is around 65 to 70 decibels. And even with the door closed, it still maintains at around 60 decibels. The Sermoon is one of the quietest printers I've ever tested, if not the quietest printer, so I will give 9 points to the Sermoon D3 and 5 points to the Ultimaker S3. For print quality, speed, and noise, the Sermoon D3 gets 51 points out of 60, while the Ultimaker S3 gets 37 points out of 60. The main disadvantage of the Ultimaker S3 is the bowed-in setup and weak part cooling. The vibration also caused some minor issues on the print surface. Overall, after using the same brand and the same type of material for different tests, the Sermoon D3's print quality is higher than the Ultimaker S3 on every single material. Next, we will jump into comparing the software, workflow, and user interface. First, for setup and workflow, both of them work pretty well. The wizard type setup guide is available on both machines, and it will guide you through doing manual bed leveling by adjusting the knobs, filament loading, and other basic setup procedures. I would say the workflow of the Sermoon D3 is better, as it doesn't require you to use a paper or card to adjust the corners of the bed, and it instead uses the CR Touch to probe the corner and tell you how much you need to turn the knobs. For setting the Z offset, it also has an independent sensor at the back of the bed to calibrate the Z offset. The nozzle will also rub itself on the silicone block to clean the nozzle before doing this calibration. So, I will give 8 points to Creality and 7 points to the Ultimaker S3. For the slicer software, the Creality print is not too bad, but the slicer features, slicing speed, user interface, and networking printing workflow is not as good as Cura. I will talk more about this later. So, I will give 4 points to the Sermoon D3 or the Creality print slicer and give 8 points to Cura. For the firmware, they both use Marlin, but the linear advanced calibration of the Sermoon D3 actually did better. As you can see, there are no more overshot corners on the calibration cube, but you can still see them on the Ultimaker S3. Besides that, there is no big difference between them. So, I will give 7 points to the Sermoon D3 and 6 points to the Ultimaker S3. For network printing, Cura's network feature is integrated with the Ultimaker printer quite well. Just click Slice and Print over Network, and the printer will start the job right away. For Creality Print, you need to click Slice and then Upload. Select Upload to Printer instead of Creality Cloud, make sure the printer is connected, select it, and click Send the G-code file. Then, open the printer window, but it won't print yet as you still have to select which file to print. Select the file, click Print, and finally confirm that the build plate is clear. Selecting multiple different things and requiring 8 clicks to start a print is not what I expected to see. It still works, but this kind of workflow just isn't good. Also, I can't see my 5G Wi-Fi network using the Sermoon D3. As a new printer in 2023, it can still only connect to a 2.4G network, which is too outdated, especially as the 4-year-old Ultimaker S3 can connect to both 2.4G and 5G networks. So, for network features, I will give 4 points to the Sermoon D3 and 7 points to the Ultimaker S3. Now for the touchscreen interface, the UI of this Sermoon D3 is the best out of all Creality printers, as this time, its design makes perfect sense. It has all the information and settings you need, and the button locations are well organized. The UI of the Ultimaker is still good, and I believe it could have been the best 4 years ago, but sometimes it may show too little information and some features are not easy to access. For example, you can't see the temperature, heated bed, or more information about the current job. You need to go back and press a few buttons just to see the temperature. If you want to change it, you need to set a temperature offset instead of just entering the new value. There's also no way to adjust the Z offset if you find that the nozzle is too close to the bed and is squeezing the filament down too much. The lack of this feature may also affect the quality of the first layer. So I will give 8 points to the Sermoon D3 and 6 points to the Ultimaker S3. For this part, the Cura slicer and the integrated network printing feature of the Ultimaker S3 is the winner, but the setup workflow and the touchscreen of the Sermoon D3 are better. The total points for the Sermoon D3 in this part is 31 out of 50, and the Ultimaker gets 34 out of 50. Finally, I will compare the service and brand. For service and support, personally, I didn't use the service and support of either company, but according to what other users have said in some forums, if I said Ultimaker's support is much better, I don't think too many people would disagree with me. Documentation is also a weak spot for Creality. The Sermoon D3's documentation has improved a lot, but Ultimaker's documentation and their online knowledge base is still better than Creality. So I will give 6 points to Creality and 8 points to Ultimaker. For the brand value, this is pretty subjective, but as Creality is mainly for the hobbyist market and Ultimaker has been well known for years in business 3D printing and has a higher brand reputation, I'll give 9 points to Ultimaker and 6 points to Creality. So, for service and brand, Ultimaker is the winner. The total scores for both printers are actually pretty close. The Sermoon D3 got 142 out of 200, and the Ultimaker got 134 out of 200. If you take a look at the breakdown, the Sermoon D3 is the winner of hardware, as the specs are just so much better than the Ultimaker S3, other than the fact that it only comes with a single extruder, resulting in the hardware final score difference being just 2 points higher than the Ultimaker. For print quality, the Sermoon D3 is a clear winner. It prints better than the Ultimaker S3 with almost any material. The Sermoon D3 gains a lot of points from this part, with 51 versus 37 points, and these scores are also supported by the test prints of 8 different materials. For the software, workflow, and UI, Sermoon did a better on the workflow, UI, and firmware, but the Ultimaker does much better with the slicer and network printing, so Ultimaker is the winner. For service and brand value, the Ultimaker is the evident winner, but this is also reflected in the price of the machine. If this was not an Ultimaker with the same hardware, I don't think that printer would be able to sell for $4,500 plus $300 for just a high-temperature hot end. So, the final score of the Sermoon D3 is 142 out of 200, versus the Ultimaker S3's final score, 134 out of 200. As an Ultimaker user who has also tested out more than 70 different 3D printers, I think the score is pretty close to my actual experience. Okay, from the head-to-head comparison, you may already know the pros of the Sermoon D3, like the super solid hardware, outstanding print quality, especially as it delivered perfect results for hard-to-print materials like nylon glass fiber and other engineering-grade materials like nylon carbon fiber and polycarbonate, as well as those new and convenient features like the Auto Z offset. So I won't do another pro section to cover all of these features again. But besides that, there are also a few small details that I didn't have a chance to address in the comparison. For example, this printer comes with 2 flexible build plates, one PI and one PC plate. You also won't see a magnetic sheet on the aluminum bed, as it uses some strong earth magnets embedded inside the bed. As for the tools in the toolbox, there is an extra hot end and other better quality accessories that you can't see on other Creality printers. In addition, the enclosure sideboard on the right can be opened for filament feeding, and there are also 2 filament mounting spaces. If the filament is more moisture sensitive, you can put it inside, and otherwise, you can use the spool holder to mount the filament on top of the printer. The HEPA filter really works. I can't smell anything in my room when the printer is fully enclosed, even when printing ABS, ASA, or nylon. And after the print is finished, the inside of the printer still does not smell that bad when compared to other fully enclosed printers. Now for the cons. 1. The biggest question I would ask is, why is Creality still using a single extruder on a machine that is marketed towards business customers and industrial designers? A second extruder for printing soluble or breakaway support material is necessary. 2. The print speed is not that fast. As though the 100-pound super sturdy frame helps tremendously with print quality, it doesn't help much with print speed. As the speed is still mainly limited by Marlin firmware, without input shaper compensation from Clipper firmware, I won't consider it a fast printer. The latest Marlin version 2.1.2 supports input shaping. I haven't tested it out yet, but it doesn't support using an accelerometer for calibration, and as the calculation is also limited by the speed of the STM32 processor that just runs at 168 MHz, I am not sure if it can work as well as Clipper. As the 250 mm per second top speed doesn't mean a lot to me if the acceleration is only between 1000 to 3000 mm per second squared. 3. There is a sticker telling the users to remove the cover if the internal temperature is over 30 degrees Celsius when printing PLA or flexible TPU. But there is no temperature sensor inside, nor is the internal temperature shown on the screen. So the user would never know the temperature unless they put another thermometer inside the enclosure. It would be better to let the firmware control the internal temperature by turning the chamber fan on and off automatically. 4. The new nozzle cleaning feature is nice, but it only does this when using the screen UI to do platform calibration. It would be better to do this before every print to wipe off the residue from the nozzle. 5. There are still some minor issues with the slicer and screen UI. For example, when sending print jobs using the local network without using the Creality cloud, the estimated print time and the thumbnail are not showing. Even when printing offline using the USB drive, the estimated printing time is still way off. The print profiles on the slicer are not well organized. Every material has 4 profiles at different speeds, and the list is also not sorted by alphabetical order. If you change anything in the profile will show up at the end of the list. Using a drop-down list to let the user select filament type and then print speed would be better. 6. The network printing workflow of the slicer can also be improved, as it currently requires selecting too many things before you can actually start the print. The printer also can't access 5G Wi-Fi network, so you still need to have an old 2.4G band Wi-Fi network for this printer. The Wi-Fi module of this Sermoon is still the same as the Creality Wi-Fi box that was designed for Creality Cloud. The high-specs hardware deserves something much better than the Wi-Fi box, and Creality could consider integrating the Sonic Pad. So, to address multiple issues effectively, run Clipper instead of Marlin, meaning it could print faster and provide better network printing experience. In conclusion, as a desktop printer, the hardware specs of this Sermoon D3 are exceptional, and even the Ultimaker S3 can't compare with it. The print quality is outstanding, and it prints better than the Ultimaker using every single material, and also prints faster with some materials, particularly ABS. Although there are some minor issues that need to be addressed, the overall design, screen UI, setup, and auto-leveling workflow are better than all other Creality printers. I do still like my Ultimaker S3, and it was my gold standard for desktop 3D printers. It is still an awesome printer, but after they launched the S5 in 2018 and the S3 in 2019, many other new printers with lower prices keep improving and have reached or even surpassed Ultimaker's gold standard. If I don't need to print soluble or breakaway support filament, I would definitely prefer the Sermoon D3 over the Ultimaker S3. Finally, I would like to offer a couple of suggestions to Creality. First, I would definitely want to see them launch a dual extruder version of this Sermoon D3. Second, to make it a faster printer, just a super sturdy frame is not enough. Marlin firmware is keeping this printer from its full potential, so going for Clipper is necessary, or you just can't make any significant improvements to the print speed. Third, Creality Print as a new slicer is not too bad. The integrated local Wi-Fi printing feature is usable, but all of this doesn't make this printer gain more points. Software is actually the area that made this printer lose points in my head-to-head comparison. I understand that using a Cura plugin may present a lot of limitations. Making their own slicer might be a good long-term strategy, but I believe that Creality shouldn't completely get rid of Cura yet until they know they have something better. A Cura profile and a Cura Wi-Fi plugin similar to the Moonraker plugin that allows users to print over the local network in just 2 to 3 clicks are what I prefer to see with this printer. Finally, the Creality Cloud may not be the best option for business customers. The only thing these customers care about is printing, and they may not want to see all the events, promotions, and community news all over the screen when they open Creality Cloud. For business users, they're most likely using professional CAD software like Fusion 360 or SolidWorks to design their parts and just want to use the slicer for printing those parts. For network printing, they may not even want their files to go to Creality Cloud at all, and will instead keep all the design files inside the local network, which may sound more reasonable. All of this needs to be taken into consideration when designing a machine for the business market, as it may be quite different from the hobbyist market. But overall, this Sermoon D3 is a huge step up for Creality. The hardware specs and print quality are top-notch, and if they can address what I mentioned in this video and make this printer more suitable to business customers, I believe they could challenge Ultimaker in the business 3D printing market. That's all I have to share about this printer. Thank you for watching, and I will see you next time.